Hello friends, welcome to EC Academy. In this lecture, let us understand the concept of supermesh analysis, which is a powerful technique for solving the circuits that include ideal current source, which often makes the traditional mesh analysis difficult. We'll take an example to understand the supermesh analysis step by step. Let us consider this circuit as shown in this figure. It consists of three mesh as shown in this figure. Here, two mesh 1 and 3 will share the ideal current source. The voltage source is 10 volt between point A and B. The resistors in the circuit are 2 ohm, 3 ohm, 4 ohm, 5 ohm and 6 ohm. The circuit has 5 ampere ideal current source between D and E. Here, our main goal is to find all mesh currents or loop currents using supermesh analysis. So why do we use supermesh? When a mesh contains an ideal current source, you cannot directly write KVL because the voltage across the current source is unknown. In this circuit, the current source is between mesh 1 and 3, where we can use the supermesh technique. Now let us see how to form the supermesh. A supermesh is formed by combining mesh 1 and mesh 3 by bypassing this current source. In this circuit, the supermesh can be considered through the path A, B, C, D, G, H, E and A. Now let us assign the mesh current as follows. We have I1 in loop A, B, C, D, E, A. We have I2 in the loop D, C, F, G, D. And we have I3 in the loop E, D, G, H, E. In the first step, let us apply KVL for supermesh. In the supermesh, we are having a voltage source and we are traversing the voltage source from negative to positive, which is voltage rise. So we can write that as plus 10 volt. The voltage drop across 2 ohm resistor can be minus 2 into I1 minus I2. The voltage drop across 4 ohm resistor is minus 4 into I3 minus I2. The voltage drop across 6 ohm resistor will be minus 6 into I3 will be equal to 0. Now let us expand this and we can write 10 minus 2I1 plus 2I2 minus 4I3 plus 4I2 minus 6I3 is equal to 0. If we simplify this, we can write this as 10 minus 2I1 plus 6I2 minus 10I3 is equal to 0. Or we can write the above equation as, if we send this term towards right hand side, we can write 2I1 minus 6I2 plus 10I3 is equal to 10. So we can write it as I1 minus 3I2 plus 5I3 is equal to 5. Let us call this as equation number 1. Now once we apply KVL to supermesh, now there is one more mesh that is left out. So we can apply KVL to this loop or mesh. So let us apply KVL or mesh 2, which is T, C, F, G, D. The voltage drop across the resistor 2 ohm will be minus 2 into I2 minus I1. The voltage drop across the 5 ohm resistor will be minus 5 into I2, and the voltage drop across 4 ohm resistor will be minus 4 into I2 minus I3, that will be equal to 0. Now let us expand the above equation. We'll get minus 2I2 plus 2I1 minus 5I2 minus 4I2 plus 4I3 is equal to 0. So we can write above equation as 2I1 minus 11I2 plus 4I3 is equal to 0. So let us call this as equation number 2. Now we have the current source between D and E, which is 5 amperes. The 5 ampere current source lies between first mesh and third mesh. So we can write I1 minus I3 will be equal to 5 amperes. So the current source 5 amperes between the mesh 1 and 3 can be written as I1 minus I3 is equal to 5. Let us call this as equation number 3. Now we have these three linear equations. Let us solve these three linear equations to find the loop currents in the given circuit. Now let us consider equation number 3, and let us substitute equation 3 in equation 1 and 2. So from this equation number 3, we can find I3 is equal to I1 minus 5. So let us substitute I3 in equation 1. Therefore, we can write I1 minus 3 I2 plus 5. In place of I3, we can write I1 minus 5 is equal to 5. Let us expand this equation. We'll get I1 minus 3 I2 plus 5 I1 minus 25 is equal to 5. So we can write the above equation as 6 I1 minus 3 I2 is equal to 30. Therefore, we can write 2 I1 minus I2 is equal to 10. Let us take this as equation number 4. Now, let us substitute I3 in equation number 2. Therefore, we can write 2I1 minus 11I2 plus 4. In place of I3, we can write I1 minus 5 is equal to 0. So we can write this as 2I1 minus 11I2 plus 4I1 minus 20 is equal to 0. So if we simplify the equation, we'll get 6I1 minus 11I2 will be equal to 20. Let us call this as equation number 5. Now in the next step, let us solve equation 4 and 5. So here let us multiply equation 4 by 11. Therefore, we can write 22I1 minus 11I2 is equal to 110. Let us call this as equation number 6. So we have multiplied by 11 to make the term I2 in equation 4 and equation 5 as same, so that once we subtract, we'll get the value for I1. So let us subtract equation 5 from equation 6. Therefore, we can write 22I1 minus 11I2 minus 6I1 minus 11I2 will be equal to 110 minus 20. So if we expand the above equation, we'll get 22I1 minus 11I2 minus 6I1 plus 11I2 will be equal to 90. So here we can cancel out these two terms and we can write the above equation as 16I1 will be equal to 90. So from this we can say I1 is equal to 5.625 amperes. Now let us substitute I1 in equation number 4. Therefore, we can write 2 into 5.625 minus I2 is equal to 10. So it will be 11.25 minus I2 is equal to 10. Therefore, I2 will be equal to 1.25 amperes. Now we can find I3 using equation number 3 by substituting the value of I1. Therefore, we can find I3 from equation number 3. Therefore, we can write I3 is equal to 5.625 minus 5. So, I3 will be equal to 0.625 amperes. Now let us verify our answer. Between the point D and E, 5 ampere current is flowing. So which means I1 minus I3 should be equal to 5 amperes. So I1 is 5.625 and I3 is 0.625. So if we subtract these two values, we'll get 5 amperes. So our calculation is correct. Now let us consider an example to solve using supermesh analysis. Here we need to find the values of all mesh currents in the network using supermesh analysis. So here you need to note that the network is having voltage and current sources in such a way that we can't apply KVL directly. So this is one of the perfect example to apply the concept of supermesh. In the problem, the loop currents will be given, or you need to assume the loop currents in clockwise direction. Let us define the mesh current or loop current. The current I1 is in the mesh for the loop A, B, M, A. The current I2 is in the mesh for the loop B, C, M, B. I3 is in the mesh for the loop A, M, D, A, and I4 is in the mesh C, D, M, and C. So from the network, I2 minus I1 will be equal to 3. So we can write I2 minus I1 is equal to 3. Let us call this as equation number 1 between the points B and M. Now between M and C, we can write I2 minus I4 is equal to 1. So we can write I2 minus I4 is equal to 1. Let us call this as equation 2. So this is written between the points M and C. So first equation is between the points B and M. Now between the point D and A, the current I3 will be equal to 2 amperes. So we can write the current I3 is equal to 2. Let us call this as equation number 3. So this is written between the points D and A. So we got 3 equations. Since we are having 4 currents, we need to find 4 equations. To find the fourth equation, we can use the concept of supermesh, excluding the branch with current source. We can apply KVL to the loop A, B, C, D, M, and A. So we can exclude the branches with current source and we can form the super mesh. So let us consider the super mesh. For this super mesh, let us apply KVL. Across 1 volt battery, there is a voltage rise. So we can write plus 1 volt. The voltage drop across 1 ohm resistor will be minus 1 into I1. Voltage rise across the battery is 3 volts, so it will be plus 3. The voltage drop across 1 ohm resistor is minus 1 into I2. Voltage drop across 1 ohm resistor will be minus 1 into I4. The voltage rise across the battery will be plus 5. Voltage drop across 1 ohm resistor will be minus 1 into I4 minus I3, and the voltage drop across 1 ohm resistor will be minus 1 into I1 minus I3 will be equal to 0. Now let us send all the current values towards right hand side and we can write 2I1 plus I2 minus 2I3 plus 2I4 will be equal to 9. Therefore, let us write this as 2I1 plus I2 plus 2I4 will be equal to 9 plus 2I3. Let us call this as equation number 4. Let us substitute equation 3 where we are having I3 is equal to 2 in equation number 4. Therefore, we can write 2I1 plus I2 plus 2I4 will be equal to 9 plus 2 into 2. So, this will be equal to 2I1 plus I2 plus 2I4 will be equal to 13. Let us take this as equation number 5. Now, let us express I2 and I4 in equation 1 and 2 in terms of I1. Therefore, from equation 1, we can write I2 is equal to 3 plus I1. Let us call this as equation number 6. And from equation number 2, we can write I4 will be equal to I2 minus 1. So this will be equal to 3 plus I1 minus 1. So I4 will be equal to 2 plus I1. Let us call this as equation number 7. Now let us substitute equation 6 and 7 in equation number 5. Therefore, we can write 2I1 plus 3 plus I1 plus 2 into 2 plus I1 is equal to 13. 2I1 plus 3 plus I1 plus 4 plus 2I1 is equal to 13. So let us group I1 term. So it will be equal to 5I1 plus 7 is equal to 13. So 5I1 is equal to 6. So from this we can say I1 is equal to 1.2 amperes. From equation 6 we can say I2 is equal to 3 plus 1.2, that will be equal to 4.2 amperes. From equation 7 we can say I4 is equal to 2 plus 1.2, that will be equal to 3.2 amperes. So we got all the mesh currents. So we can say the mesh currents are I1 is equal to 1.2 ampere, I2 is equal to 4.2 ampere, I3 is equal to 2 ampere, and I4 is equal to 3.2 amperes. Now let us cross verify this. I2 minus I1 should be equal to 3 amperes. So 4.2 minus 1.2, it is 3 ampere. I2 minus I4 should be equal to 1 ampere. So I2 minus I4, 4.2 minus 3.2, it is 1 ampere. And I3 is 2 ampere. So our calculations matches with this given circuit values. So in this video, we demonstrated mesh analysis with supermesh approach. We solved the mesh current and validated our answers step by step. Hope you have understood this topic. Thank you.